Gene regulation in prokaryotes occur in specific regions in DNA called operons. The type of operon that we'll talk about today is called the lac operon. The lac operon is found in E. coli bacterium that reside within the intestine of most mammals. And the purpose of the lac operon in E. coli is that it will produce proteins that will aid in the digestion of lactose for that organism. The lac operon is negative inducible, meaning that when no lactose is present, no transcription will occur, because the repressor is bound to the operator, turning transcription off, blocking RNA polymerase. This is our legend. Lac I plus codes for a repressor. Lac P plus is where the promoter is, and that's where RNA polymerase will join and transcribe genes. And Lac O plus is where the operator is, and it's off and on switch for transcription. For instance, say that you're going to see Old Faithful Geyser in Yellowstone National Park. And just to give us some guidance, the legend right here has RNA polymerase as our car, the promoter in DNA is the road, and the hungry bear is the repressor. And then structural genes are just that we get to see the geyser, and the allolactose or the small molecule is the park ranger. So say we're driving and the bear gets in the way and it wants some food in the middle of the road. You can't get to the geyser, sadly, because it stopped you from getting to Old Faithful, and in the sense of reality, there's no structural genes made because the bear's in the way. The repressor's there. So we call in the park ranger. The park ranger is right here, and he sees like, oh, we gotta get the bear out the way. It's gonna get to that hungry bear, and then it's gonna deactivate that bear, and the bear's gonna just run away into the woods and find something else to eat. And then as we see here, RNA polymerase is allowed to go from the promoter all the way to the structural gene region where we also can get to Old Faithful. The small molecule causes the repressor to undergo an conformational change that it can no longer bind to the operator. If the small molecule wasn't present, then it wouldn't be able to bind to the repressor, and then the repressor just goes to the operator and turns transcription off.